This is a drug Fedratinib, which is a potent selective ATP competitive orally active BRD4 inhibitor. It induces cancer cell apoptosis and has been shown to reduce inflammatory cytosine levels in patients with myelofibrosis. It works by displacing BRD4 from chromatin, therefore interfering with its function as a recruitment module. Looking at the molecule, at the far left we see this pyrrolidine group, and as we go along we see the oxygen next to the aromatic ring. We then get to an amino functionality here next to the 5-methyl pyrimidine ring, the ring here containing the 2 nitrogen. As we reach this pyrimidine portion, we start to see a kink in the molecule as it changes direction, and we again see a second amino functionality here, which is next to the sulfonamide group here, which contains the aromatic ring, the sulfur dioxide, and the T-butyl coming off of the nitrogen here. So once we add the interactions, as you can see, there's quite a bit going on here. However, we see several hydrogen bonding interactions between the Fedratinib and the receptor, shown by these dotted lines here. So here we see a hydrogen bond between the secondary amine group of the drug with the oxygen from the carboxylic acid portion of the P82 amino acid, which is the proline amino acid portion of the drug. So Fedratinib revealed an acetyl-lysine mimetic binding mode where the secondary amine nitrogen here, as well as the nitrogen present in the 5-methyl pyrimidine ring system, they form the two hydrogen bonds with the amide group of the asparagine amino acid, which is this N140 portion here. So like I said, there should be a dotted line showing the hydrogen bonding with the NH2 portion, as well as this dotted line that's here showing the hydrogen bonding between the secondary amine with the oxygen portion of the amide group. When adding the solid receptor surface, as you can see, it gets quite busy. I want you to draw your focus to the L92 portion, because in addition to the other hydrogen bonds that I mentioned, the sulfonamide oxygen, which is here on our molecule, as well as the pyrrolidine nitrogen, which is up here, they actually form additional water-mediated hydrogen bonds with the ZA loop backbone, which is this L92 portion here, the leucine amino acid. I would like to also draw your attention to this methyl substituent here, which is the methyl substituent coming off of the 5-methyl pyrimidine, which is oriented towards the bottom of the acetyl-lysine binding pocket, which is also occupied by conserved water molecules in this structure as well. So as you can see, it's peeking out in this little area here. Then we'll look at the T-butyl substituent up here, which is oriented towards the shelf region of the BRD4 receptor.